Hi, this is Gary Esparza.
Marco Garza.
Hi, Yusha Marquez. This is Physics 1301, and this is our Heat Communication Skills project. The purpose of this assignment is to improve our understanding about some physics concepts, such as conservation of momentum, conservation of energy, heat, and friction, as well as to improve our communication skills by explaining the concepts that we are covering and the steps to find the solution for each problem. We will be working on two types of problems. Problem number 1 requires for us to find the number of steps that we will need to climb the stairs to lose the energy gained from eating a candy bar. Problem number 2 will require for us to analyze the collision between the bullet and a wooden block. My mass is 52.27 kilograms and I am going to eat a 210 calories Kit Kat. How many stairs must I climb to work off the Kit Kat? For my calculations, I will use the height of the steps of TSC stairs, which is 18.0 centimeters. This is what we know. My mass, which is 52.27 kilograms, the height of each step, which is 18.0 centimeters, which we convert to meters, making it 0.18 meters. We know that 1 Kit Kat equals 210 calories, so we can let 1 Kit Kat be Q, which is heat, and heat is energy due to change in temperature. What we need to find is the number of steps I will need to climb the stairs to lose the energy gained from the Kit Kat. In order to find the number of steps I need to climb, I will need to solve for the height to climb, which will be capital H. Now that we know what we have and what we need to find, we can begin to solve the problem. Step 1. Use the mechanical equivalent of heat to convert the calories into joules, using the food unit calories with the capital C, which is 4,186 joules over 1 calorie. Calories cancel out, leaving me with joules, so the new heat is 8.79 times 10 to the 5th joules. Step 2. Conservation of energy can be converted into thermal energy. Conservation of energy can be defined as energy that may be transformed from one kind into another in an isolated system, but it cannot be created or destroyed. So in this case, it equals to 0 because when I eat the Kit Kat, I'm gaining and creating energy. Now we can go ahead and let heat equal to work. Step 3. We already know that work equals mass times gravity times height. So we can go ahead and let heat equal to mass times gravity times height, and solve for the h, which will be the height to climb. Next, we plug in the values we already know. Now that we already know the height to climb, we divided by 0.18 meters the height of each step to get the number of steps I will need to climb to work off the Kit Kat, which will be 9,533 steps.
A lead bullet with a mass of 8 grams is traveling with a velocity of 120 meters per second when it strikes a wooden block. The block has a mass of 5 kilograms and is at rest on the table, as shown in the diagram below. The bullet beds itself in the block, and after the impact they slide together. All the kinetic energy is lost in the collision and is converted into heat. Assume that all the heat goes into heating up the bullet. So do I have to explain more than that?
I don't know, does it explain everything?
What is the speed of the wooden block after the collision? For this problem, we will be using the conservation of momentum. Conservation of momentum is a fundamental law of physics which states that the momentum of the system is constant if there are no external forces acting on the system. What's known: M, mass of the block, is 5 kilograms. Mass of the bullet is 0.16 kilograms. velocity of the bullet is 120 meters per second. Find the final velocity. Mass of the block times velocity plus mass of the bullet times velocity divided by mass of the block plus mass of the bullet equals final velocity. Five times 0 plus 0.16 times 120 divided by 5 plus 0.016. .38 meters per second. B. How much heat is generated as a result of the collision? And for this problem, we will be using friction. Friction is the force resistant the relative motion of solid surface, fluid layers, and material elements sliding against each other. Known. And mass of the block is 5 kilograms. Mass of the bullet is 0.16 kilograms. Velocity of the bullet is 120. Final velocity is 0.38 meters per second. Find heat. 1/2 mvm for the block plus 1/2 mvm for the bullet equals half m plus m v velocity squared plus q. Q equals 1/2 mv for bullet squared minus 1/2 m plus m final velocity squared. Q equals 1/2 times 0.016 times 120 squared minus half times 5.016 times 0.38 squared equals heat 115 joules.
By how many degrees does the temperature of the bullet rise after the collision? The specific heat of the bullet is 128 joules over kilograms Celsius. No. Q equals 115 joules, or C equals 128 joules over kilograms Celsius, and our mass is 0.016 kilograms. We are going to find change in temperature. So for this, we will use Q equals Cm, change in T, to where change in T equals Q over Cm, which then translates to Qt equals 115 joules over 128 joules over kilograms Celsius times 0.016 kilograms. The result is a change in temperature of 56.2 degrees Celsius. Suppose that the table has a coefficient of kinetic friction of mu. What is the acceleration of the block? Our known is mu equals 0.4, our mass is 5 kilograms, and gravity equals 9.8 meters per second squared. And we're finding A. Friction equals mu times normal force, or mu times mass times gravity. Newton's second law states that friction equals mass times acceleration. Therefore, acceleration equals friction over mass. To get that, we have to multiply 0.4 times 9.8, and the masses cancel. That leaves us with an acceleration of 3.92 meters per second squared.